Hi guys, welcome back on the second part of the Victorian architecture breakdowns. Before going further, I would encourage you to look at the first video if not already done, as I will skip some of the notions we've already seen in this one. And today we want to focus on the buttress, okay? As usual, I run my work on solid photo reference so we know what features we need to implement. Before diving into it, I know what you are asking yourself. What's a goddamn buttress? Well, you may also have heard of the term counterfort, and it usually describes an architectural element built against a wall to hold the structure together, reinforcing the walls. Now, the reason why this element was used so much in the Gothic architecture was to allow and improve the verticality of the edifice, thinking the taller it would get, the more it would bring the people closer to God. Well, I know you can't wait to start modeling and you're already tired of history lessons, but let's just look at some photos real quick. So looking at this building, I definitely feel that we can have the buttress and its tower separated to make things easier down the line. Even the buttress itself feels like there is a top part with two halves of arches and a bottom part with just one big arch. And the split between top and bottom will of course drive the look of the tower at the end. To be able to iterate and have full artistic control over this element, I exposed a bunch of parameters so we don't need to deal with a large network in the end. Very much like a gizmo nuke, this way you can quickly change the thickness, overall length, also tweaking the tilt while affecting the towers, or even change the separation between the top and bottom. Well, if you still think Houdini isn't suited for modeling complex environment, well, I don't know what to tell you at this point. Of course, depending on your experience, it will take more or less time to set up. Like everything, it is very much a learning process, so keep in mind at some point, or pretty much at every point to be honest, you are going to fail. You will be so depressed, you will want to remove this app for good. And I'm talking here from experience. My learning was brutal and that's why I'm trying to make it easier on people. So keep trying, and before you realize it, your brain will be rewired for this kind of approach and solving problem will become a second nature, don't worry. Wow, sorry, I completely digress here, but I'm sure you understand. In this video, I'm going to break down the foundations of this non-destructive system. So without further ado, let's dive in. Alright, let's see what we have. We want to focus on this buttress backdrop today, so how does this start? I am feeding here this piece of geo, which is a component of the main structure that we need to reinforce with the buttress. I'm using here a bound to simplify this geo. The idea is to extract one face out of this cube that would rest against the main structure and would be the base for our buttress. I'm making it a bit thinner by scaling in X, then starting to trim the top part using a knife sop, just so the buttress won't start at the very top of my original pillar and we leave some room for it to breathe. Then we can define the depth of this buttress by simply poly-extruding this face. To give some tilt on the top left edge, I just manually loaded it in Y with an edit sop. And using a new knife to trim one piece of the buttress, the idea is to keep the leftover portion that will end up shaping the tower. And thanks to this, I can start building derivation in my graph. This branch can focus on the buttress by blasting the above plane group generated by the previous knife sop, and we just have the buttress part. Then we need to start shaping it. So far it's a very simple mesh, as you can see. And I noticed on my original photo, the top of the buttress actually have a pretty sharp edge right in the middle. So we can just use a new knife sop to slice the geo on the Z direction and slightly elevate this edge with an edit. So with, without, it's still looking very simple for now, but the idea is to block out the key elements step by step. Moving on, I'm here actually trimming the bottom part of the buttress. How do I know where to cut though? I'm just simply looking at reference, and I noticed that the bottom of the buttress here is defined by the bottom part of the window. If we start drawing some lines, here we notice that it basically fits on the same plane. So what we want to do is use the window shape as a way to drive the height of the buttress in this setup. And basically, I'm calling here a second geometry, which is the shape that cut out the windows of the main structure. I'm extracting the bounding box and keeping the bottom face only, and using it into the second input of a boolean to get rid of what's below this plane. The proportions are now almost defined. We need a few more things though. We need first the center edge that will separate the couple of arches located on the top part. To do so, I'm reusing my favorite SOP, the knife, to slice the geo and generate groups above and below the slicing direction. And of course, I can always move it from the origin point I defined. In that case, I define it using a point expression in Z, just like I've been showing in the first video. Anyway, thanks to the groups generated by the knife, we are able to position and actually dig some arches in this wall. Yay! So that's what I'm doing with this boolean, and then I also have this one that extracts this bit. So let's see exactly how I made that happen. So on one side, I started by extracting the above plane group. Then I just simplify it with a bound and using some padding to make it thinner. To actually add divisions, I'm here using box SOP and setting axis divisions in Z. 32 should be enough to get a good resolution down the line. So I showed how I made a similar node in the first part when talking about the windows. We can use it at our convenience to give this box a nice curved shape on the top. I'm then lowering the geo a little bit, give some extra margin from the top, and end up by trimming a good chunk of the bottom part. And I'm doing the similar thing with the left arches, which is a smaller one. The final boolean that trimmed the bottom is basically a grid that slices our arches the same way than we did with the windows defining the height of the buttress. Same concept here, except that it split the top and the bottom part of our buttress. Moving on, we want to shape this a little bit more, and we'll start by extracting the faces pointing up using a group and keep faces by normal. Of course, I'm not interested yet in the two polygons at the bottom, so I'm first blasting everything but the top group, and then using a boolean to trim the polygons at the bottom. So it's connected to a bound and using the margin to actually get rid of those. Then we have a divide SOP that basically allow with this breaker polygons feature to add more divisions. Size D and offset Z will allow you to adjust the spacing and the position of those divisions. Of course, I left one edge in the middle for some reason. Ideally, I should get rid of it, but well, whatever. We're gonna move on, and from here we can do an inset of all those individual polygons using a poly extrude SOP. Just make sure divide into is set to individual elements, and let's export from group. At this point, we can do a new extrude, and this is just calling the extrude from group that we just created, and we give it some thickness. I think we'll see better if I switch to wireframe. Finally, this ID generator was just to create random values per connected elements and use those variations to drive some shader breakups in the diffuse. I actually offer this node as part of AL model utility on my gumroad. The UI is a bit better and allow to either store a float or color data into an attribute called ID by default. So extremely simple tool, but that helps me to get things done a little bit faster in all my projects. Anyway, moving on. Looking at the final treatment of this top buttress, I actually did the same tiling treatment on the faces in the bottom. Also, I beveled the edges generated by the boolean cutout. Because if we look at the reference again, we do notice those edges are not that sharp, and it helps make the model more elegant. Now, what I want to show you is how to approach this kind of connecting geometry. So this is the final result of this piece. The first thing you want to do would be to get a combined model of the basic shape you want to extract. For example, this is just a bit fusing different pieces of the tower, just leaving the operation to union in this case, and I am then combining the rest of the buttress, the bottom part actually. So that's awesome. What's left there is getting a slice of this model, and to do so, I'm using a grid that references the lowest point of the top buttress. And I'm shifting it just a little bit to be sure it intersects with this cornered tower area. In terms of Boolean operation, I am then setting it to seam, and it allows me to extract a nice curve out of the main shapes. So that's great. I'm then reassigning the offset I applied to be sure it's at the proper position. Doing a convert line, this allows me to extract one primitive per segment. Not even sure to remember why I did that. I think I kinda needed it on another section to clean some weird stuff, so you may not need it, and same for the next couple of nodes. Polypath is basically doing the opposite of convert line. It's taking all the primitive and merge it as one. Well, in that case, those might not be needed. Probably you can turn it off. Oh, wait a minute. Actually, it's doing something. It's cleaning this weird bit here. I think, yeah, the boolean was a bit weird and I needed that to fix a little bit the shape and make it straighter. Yup. Well, then I'm using a resample to add more points evenly spaced. Just make sure resample by polygon edge is checked so it preserves the integrity of your segments. Just right here. So you can see by yourself, when turned off, the shape is pretty messed up here. Not as sharp as before. And of course, you will have length that drives the spacing of those points. Moving on, what have we here? AL section curves. It is a pretty simple HDA. As you can see, it's now fracturing my curve into small bits. Each of these small bits will correspond to bricks later on, because if we look at how things are made in real life, you can't exactly carve such a tricky shape in one piece. You'd very much make your life easier and assemble bits by bits. Let's see how this is actually set up. Maybe there's some good tip you can get from it. Okay, so those first nodes were basically what we just set up previously. It was first included in it, but then I decided to disable them. So let's disregard those. The most interesting thing here is the group by range. I am storing a selection of points into a group called divide. I am here playing with the range filter to do my selection. On the other side, I am using a facet sub with remove inline points enabled to simplify my curve. So we can see without and with, you get the idea. I am then storing the leftover points that structure the curve into a group called base PT. And what I want to do is use this group as a way to maintain the shape of the curve while deleting all the useless points in the other branch, except the divide points that we need to keep. To do so, I first transfer this group base PT to the other branch that stored the divide group. Now that base PT is transferred, I'm using group combine sub and I'm subtracting divide group to base PT. I can then use delete sub to delete all the points stored in base PT. So this is just a great way to make sure our final geo doesn't get so heavy for no reasons. Now we can use the polycut sub and call divide group in the cut points parameter. So we see new primitives created in between all the different points that we define in divide sub. So each primitive will basically correspond to one brick. Now, one very last thing, we need to define a proper orientation for the normal of this segmented curve so we can shape it properly with a sweep. I found out that it was better to actually generate the normal before the polycut. That's why I'm using an orientation along curve. Here is that I'm transferring after the polycut. Looking at normal guides, this is what you get at this point. When we transfer, we get same result on this branch. But if we would generate the normals right after, we would notice orientation gets a little bit different. Because of segmentation, the flow gets also broken. It's pretty subtle, but it's more noticeable once we shape the curve, and that's what we're gonna do now. Just like in the first part, I'm reusing a sweep sub for this kind of operation, and we need a profile, of course, to plug in the second input. So this is what I'm using. It should do the job just fine. The flow seems to work perfectly fine since we set up the normal orientation properly. And I then do some extra operation to, let's say, brickify things. And it is the purpose of this little HDA. Since I'm reusing this technique all over the building, it was important for me to streamline things, and creating digital assets was the way to go. How this works is super simple. Looks like I left this promote sub that convert the divide group into an edge group. I don't think I ended up using it though, but well, you can scratch that. Let's explode the view for a sec with explode view sub, and should help seeing what's going on. I'm basically filling the holes using polyfill sub, and also note I'm actually exporting patch group. I can then call this patch group in polybevel right here, and we get a nice bevel. So yeah, patch group, extremely useful when you need to do more operation to those field faces like bevels, extrusions, yeah, whatever. In this case, it really helps add a little bit of detail, and you call this group basically in the group parameters. Moving on, we have another ID generator to create some attributes for our shader and bring some variation. So yeah, that's pretty much it. I'm just gonna reduce that guy. There's no point of keeping it actually. So yeah, that's how I'm handling this kind of detail of brick railing thingy. Let's see what else I could show you. So the bottom arch is very much the same process for the top ones. I'm thinking maybe regarding the towers, there's like this bricks variation thingy. I don't think I explained that in the first part, so may as well try to explain it. So I'm starting off this base right here. Here we go. Some pretty weird stuff happening in the corners, by the way, but well, let's not look too closely. What I want to show you is this brick setup section. So I'm starting by fitting a line on the height of this stuff using match size, resampling it to define the amount of bricks, and using a copy to point to basically assign a grid per point that I'm gonna use to actually slice the model with a boolean. Pretty easy stuff actually, and yeah, at this point I'm happy to just do some more operation like ID generator, and yeah, that's actually super simple. So one thing we could do is apply some kind of randomness using a point jitter, and what this does, based on the scale, it's gonna more or less apply some variation. So yeah, let's see, this value seems a bit better. Still some pretty big gaps, but well, let's see how it looks. I actually don't need to apply variation in X or Z, we just want in Y. Here we go, and you see that if I'm increasing the scale, the point's gonna be more or less crazy. And yeah, this little value would allow you to apply some kind of randomness. In this case, I feel like those bricks were actually very uniform, and that's what contribute to the kind of architecture of this building. So I actually don't need it, but it's good to know that you can do that. And then finally doing some poly bevel to make sure that it's look pretty. And yeah, merging with the rest of the tower. So for that, I already show in the first tutorial how to handle the top, the columns, etc. And that's pretty much it for today. Thank you so much for watching. I wish you a very happy learning for 2022. Feel free to connect to my socials, and otherwise I will just see you in the next video.